Welcome friends. In this video we are going to look at mathematics paper 1 and we are going to look at the paper that was written by the external candidates in 2020. Now let's have a look at the first question where they were told to simplify. So to simplify simply means to make it simple. Now how can we make it simple? So let's look at what we have. So we have 2a. Now, because of the addition, 2a is on its own. Then we have b minus a in brackets. Since we have not been given a number, this simply means that there is a 1 here. Minus 2b. So whenever we have a plus or minus, it's just the separation of these variables or numbers. Now, since the numbers, including the letter that we have inside the bracket, is everything will be multiplied by 1, this has no effect. So what we can do is we can just multiply 1 times b will give us b. The 1 times negative a will give us negative a minus 2b. So this is our picture. Then upon reaching here, we can now collect the like terms. So the like terms here we have 2a, then minus a plus b minus 2b. So now we can add. So 2a minus a will just give us a. Positive b minus 2b, this will give us negative b. So this is our final answer, because we can see that what we have here unlike terms, and we know that we cannot add or subtract the unlike terms. So this is how you can simplify. Now let's look at the second question. So the second question, we can see that we are dealing with a question of indices where we have the fraction raised to another fraction. Now the other thing, we can see that the power is negative. So how do we do with the negative? So if we want, we can evaluate this problem by first we ignore the negative, then we come back to the negative. Or if we want, we can just look at this at once. So now the best way that we can do, I'm sure the simpler way is let's ignore the negative. So if we ignore the negative, what do you do if you have been given a certain power, a fraction raised to another fraction? So what is our first step that we are supposed to do? So what we are supposed to do is we can first write our square root. Then we can see that we have 64 inside over 125. So make sure that the square root is affecting the numerator and the denominator, since the 1 over 3 is affecting the 2. Now from the fraction, the denominator of the fraction is just the root. Then the numerator is the power. So what are we solving for here? We are looking for third root. So we are going to put 3 here. The third root is the number that we can multiply by itself 3 times to give us the given number. Then our power is just 1. We can see from the fraction. Then let's find the cube root of 64. So cube root of 64 is the number that we can multiply by itself 3 times. So let's try, for those that may find it difficult, you can begin by, you try 1. We know that 1 times 1 will just give us 1. Then 2 times 2 times 2 will give us 8. 3 times 3, 9 times 3 will give us 27. Then we can try 4. 4 times 4 is 16. 16 times 4 will give us 64. So we need 3 4s to give us 64. So the cube root of 64 is just 4 over. So let's proceed. Let's try 5. So 5 times 5 is 25 times 5 is equal to 125. So the cube root of 125 is just 5 raised to the power 1. Now, we know that anything raised to the power 1 is equal to that thing. So 4 over 5 raised to the power 1 is equal to 4 over 5. Now, remember, there was that negative that we ignored at first. So after you are done evaluating without the negative, then whatever that you found, you need to make it a fraction. So this becomes 1 over 4 over 5. So this is what you do. Now that negative becomes a 1 over 4 over 5. Then our final answer, whenever you have here as 1, so your focus is just look at the fraction. In a case where you have the fraction, so just reciprocate the fraction so that the number 5 goes on top, then 4 goes on the bottom. So our final answer is 5 over 4. Then for those that may find it easy to do it with at once without ignoring the negative, it's okay, you can do that. So what is important is you need to look at what works for you as a person, because sometimes what may seem simple for me may seem hard for you. So if that is the case, then you can handle it at once. So what I'm saying is, let's say you want to solve it at once. So this will be, we know that our first step, we need to make this as a positive index. So say 1 over 64 over 125 raised to the power 1 over 3. So 1 over, then we introduce the square root the way we did. 3 we said is our root, then 1 we said is our power. So the cube root of, first before we do that, let's write our 64 over 125. So here we have third root raised to the power 1. So 1 over, what is the cube root of 64 is 4, 125 is 5 raised to the power 1. So it's 1 over 4 over 5 raised to the power 1 is same as 4 over 5. Then we say since we have 1 over this, we just have to say 5 over 4. Now, where is this? Why are we reciprocating this? So we know that if we write our 1, this can be written as division. So we can say divided by 4 over 5. So let's say this is 1 over 1. So what do you do? 1 over 1, this changes into multiplication. Then whenever we change a division into multiplication, we have to reciprocate the fraction. So it's 5 over 4. Then we know that 1 times 5 will give us 5. 1 times 4 will give us 4. Thus, we said the best way, or maybe the simpler way, you just have to focus on the fraction. Now we can move on to question 3. Given that the lines 3y is equal to x plus 6 and y is equal to kx plus 12 are perpendicular, find the value of k. So for this equation where we have our k, the k is just the gradient. So this is same as we need to find the gradient of the second equation. So how can we find this gradient? Now let's go back to the first equation. So whenever you have this information of two perpendicular, let's say this is our line, we can just call it line L. Then the other one, this can be line M. So this is what it means by perpendicular. So they are meeting at an angle of 90 degrees. So what are we supposed to do? So what we can do here is let's first make y the subject of the formula of the first equation. So 3y is equal to x plus 6. So how can we make this equation the subject of formula? So we now divide by 3, also here by 3, also here by 3. We cancel, we have y is equal to 1 over 3x plus 3 into 6 is just 2. After making y the subject of the formula, where there is y, you just put m, which is the symbol for gradient. Then the focus is you just have to get the coefficient of x, including its sign. But in our case, we know that it's 1 over 3, which is positive. So this gradient is the gradient for L, 1 over 3. Now, how can we convert this gradient to make it the gradient for M with the relationship of perpendicular? So if you are the first gradient is a fraction, what you just have to do is you need to reciprocate the numbers. So what do we mean by this? What we did from the previous, where the 3 will go on top, then the 1 will go on the bottom part. So this is 3 over 1. Then you have also to look at the sign. Since the first gradient is positive, the gradient of that line must be negative of that. So which is our final answer is just negative 3. So that's what you do if you encounter a question like this. Then question 4, factorize completely. So we have 6ax minus 4ay minus 3bx plus 2by. So here we are going to factorize by grouping terms. So how can we do this? So if we can just go direct, since we know that from the first party there is at least one letter that is common. Also here there is at least a letter that is common, so we can proceed. So now let's first begin by the number. So each number can go into 6 and 4. So 2 is common here. So we take out our greatest common factor, 2. What else is common? A is common. Then after we are done with this, we open the brackets, then we divide. 2 into 6 is 3. Or what number can be multiplied by 2 to take us back to 6 is 3. Then a, we've factorized a, so the remaining part here is just x minus, then 2 into 4 will just give us 2. A is not there, so we just put y. Now let's look at this part here. So what do we have? Since the 3x is positive, so we need to make sure that we are going to take out our negative. Then we'll put b, also b is common, we can see this. Then let's divide negative b into negative 3bx. So we are just going to get 3x. So this same as negative 3bx over negative b. So we know that this will cancel, b will cancel, giving us 3x. So is what we are saying. Then here, this negative into this positive will give us the negative. So we can see that we need to have same signs here. Then we have taken out the b, so this will give us 2y. So we can see that these are the same. Then our answer is making sense. So we'll take out now one of these. So this will be now 3x minus 2y. Then 2a minus b will form a bracket. So 2a minus b. This is our final answer for this problem. Okay, so now we go to question 5. Given that A is the point and B is the point, find the magnitude vector. So we are looking for a magnitude, which is just the length Okay, so A has the coordinates -2, 1. So this is our x1. Then here we have our y1. Then let's look at our b. B will be 1, 5, where this will be x2, y2. So whenever you have a two pairs of coordinates, this is what you are supposed to do. Then the formula for the magnitude AB is, now you need to find the square root of x2 minus x1 raised to the power 2 plus y2 minus y1 squared. So this is the formula that you're supposed to use. Then from there we can now do substitution of numbers. So what is x2? So x2 is 1 minus x1 is -2 squared plus y2 is just 5 minus y1 is 1 here. Okay, let's now do math. So from the first pair of coordinates, we see that this negative will multiply with that negative, giving us a positive. So we have +2 squared plus 5 minus 1 will give us a 4 squared. Okay, so now 1 plus 2 is 3 squared plus 4 times 4 will give us 16. We can also square the first number. 3 squared is 9 plus 16. Then what do you do? We are going to add. So 9 plus 16 will give us 25. Then here we just have to find the square root of 25. So since it's a distance, you just have to write units since you are not given whether the dimensions in general. So this is what you do if you are solving for magnitude given pairs of coordinates. Now we move on to use set notation to describe the shaded region in the diagram below. Okay, so what can we do? Maybe the best way or easier way, let's now do this, maybe to make sense. So what we are going to do with this, we want to put numbers. So we'll say we'll put numbers 1, 2, 3, 4, 5, 6, 7. Because for some people, just going direct won't make sense to you. So now let's look at the relationship. So let's look at P. So any part of P is not shaded. Okay, so let's look at the elements for P. So for P we can see it's 1, 2, 4, 5. So I have written all the elements that are found in P. Now what of Q and R? So Q and R are related by intersection, because we can tell where this line with where the area is shaded. So it's an intersection kind of relationship. So we can now find Q intersecting R. So from these numbers, what are the elements? Q intersecting R. So our numbers like 5, 6. Now from the shaded part, our interest is to find the shaded part. So anything in P is not needed. So we are going to say P complement, it's not needed. Intersecting, so whatever, every element in P is not needed. So whether it is found in P or Q intersecting R is not needed. So which element is found in P and intersecting Q Q and R. So we can see that 5 is common. So let's remove 5. So what do we have after we remove 5 is 6. So this is the number that we are looking at, and we can see here. So the answer will just be P intersecting P complement intersecting Q intersecting R. So this is our best answer here. Okay, so now we move on to question 7. Given that A is equal to 2, 3, 1, 0, B negative 1, 0, x2, and C 7, 6, negative 1, 0, find C transpose. So the transpose of a matrix is just that we are supposed to change the first row of the first column, matrix, will give us the first row, So the first row in C is 7, 6. So this become our first column, so 7, 6. Then the second row, which is negative 1, 0, become our second column, negative 1, 0. So this is our transpose of that matrix. Then find Bx for which AB is equal to C. For which AB is equal to C. So let us write our formula. AB is equal to C. So we'll begin by first writing the elements in A. So in A we have 2, 3, 1, 0. Since these two letters are attached to each, it means we are supposed to multiply. So A will be multiplied by B. So in B we have negative 1, 0, x2. Then we are told the product of these two matrices must be equal to the matrix for C, which is 7, 6, negative 1, 0. So this is what we are now going to use to find the answers. So what do you do if you are dealing with multiplication? So we are going to use the row by column. So how do you do? So the first row is this number multiplied by this column. So that's what we are going to do. So say 2 times negative 1 plus 3 times x. So we are done with the first column. We go to the second column, the same pattern. 2 times 0 plus 3 times 2. Then we go to this one. 1 times negative 1 plus 0 multiplied by x. 1 times 0 plus 0 times 2. Then we equate to matrix C. So from this we are going to form the equation. So we can now do the first part. We can just focus on the first part where there is x. It's okay. Now 2 times negative 1 will give us negative 2. 3 times x will give us 3x. 2 times 0 is just 0. Plus 6. 1 times negative 1 is negative 1 plus 0. Then it's 0 plus 0. Then equal to this. So the first part here, 7, 6 is negative 1, 0. So we can see that maybe let's simplify it so that you see what I'm talking about here. So the first part, we'll just leave it like that. We know that these are unlike terms, so we'll just say negative 2 plus 3x. 0 plus 6 is 6. Negative 1 plus 0 is negative 1. 0 plus 0 is just 0, equal to this. Now, is this making sense? Yes, it's making sense. We can say that this number is equal to this number. We call these corresponding numbers. This 0 is equal to this. This 6 is equal to this. So whatever that we have here must be equal to 7. So what do? You say negative 2 plus 3x is equal to 7. Then let's collect the like terms. So this will shift to this side. 3x is equal to 7 plus 2, which is, here we have 9 over 3 over 3. So x is equal to 3. Is this making sense? Let's check. So we know that the expression is negative 2 plus 3x, which is negative 2 plus 3. Here we put 3, which is negative 2 plus 9, which is equal to 7. This tells us that here, the whole thing is equal to 7. So we can say that it's corresponding to this number here. So that's what you do. So we move on to question 8. Given that the 11th term of an arithmetic progression is 43 and that the first term is 3, find the common difference. Okay, so we have the first term. So let's make a list of numbers. So first term, second term, third term, fourth, fifth, sixth, seventh, 8th, 9th, 10th, 11th. So that's the picture. So we have 2. Now the first term is 3. So we have a 3 here. Then the 11th term is 43. So how can we find the common difference given the first and the last term? So we can now use the formula. So the formula is Tn is equal to A plus n minus 1 times d. So n for this one will be equal to 11 because we have 11 terms total. So now where there is Tn, you put the last number. So the last number is 43. So whenever you are trying to find the common difference, given the last number where there is Tn, you put that number. Then A, we have the A is 3 plus n, we know that n is 11 minus 1 times d. So what do? We have 43 is equal to 3 plus 11 minus 1 will give us 10 times d. 43 is equal to 3 plus 10 times d will give us 10d. What do? Collect the like terms. So this 3 will shift to this side, giving us 43 minus 3 is equal to 10d. Then 43 minus 3 will just give us 40, which is equal to 10d over 10 over 10. So our common difference is 4. So this means that for each term you must add a 4. So let's try if this will make sense. So 3 plus 4 will get 7, plus 4, 11, plus 4, 15, plus 4, 19, plus 4, 23, plus 4, 27, 27 plus 4, 31, plus 4, 35, plus 4, 39, plus 4, we have 43. So our answer is making sense. Now, for B, we just want the fourth term. So from this list of numbers, our fourth term is 15. Or if you want, we can find it using the formula. So our formula is Tn is equal to A plus n minus 1. So fourth term, where this n, we put 4. Then what's our A? Our A is 3 plus 4 minus 1. Our common difference is 4. So 4 minus 1 is just 3 times 4. So it's 3 plus 12. 3 plus 12 will give us 15. So we are still getting the same answer here. Okay, so we have question 9a. A plane flying at a speed of 900 knots takes 5 hours to fly from town A to town B. Calculate the distance between the two towns. So the formula is speed is equal to distance over time. So over 1, we cross multiply. 1 times d is just d. So whenever we are finding for distance, we are just supposed to multiply speed times time. So as our speed is given 900 knots times 5 hours. So whenever you are multiplying numbers, or a number that has 0 with a number without 0, so our focus is just multiply 9 times 5, which is giving us 45. Then you add the zeros. And whenever you are calculating the distance, when the speed is in knots, your distance should be in nautical miles. Then point Q on longitude 85 degrees lies on the equator, okay, on the equator and is due east of P. The time difference between P and Q is this. Calculate longitude. Okay, so maybe let's see if we can make an illustration. So we have north, south, west, then east. Now point Q has this, lies on the equator, so we need the equator, and we know that the equator has 0 degrees. Then lies on the equator and is due east of P. Okay, is due east of P. So P is on the west party. We don't know where it is, but it is just on the west party. So this is our Q, and this Q is 85 degrees east. Okay, so now how can we find the longitude on which P lies? So since we are given time difference between the two towns, we can find the theta, or the difference. So how do you find the difference given the time? So you just have to multiply 15 times the number of hours. So in our case, we'll say 15 times 5. So 15 times 5 will just give us 75 degrees. Now, how if Q is on longitude 85 degrees east, and the difference between the two is 75. What is the longitude for Q? So I mean should be P. So P will be on longitude 10 degrees east. So why do we say this? Because we can see that the difference in longitude is 75, but the longitude given is 85. So the difference that we have is less than 85. So to find this one, you just have to subtract. So for you to subtract, you need to have longitude on the same side. So what you just have to do is you just have to say 85 minus 75. That is where the 10 is coming from. So maybe let me see if I can try to redraw. So this is where our Q is. This is our Q. So our P is somewhere here. So this is our P with 10 degrees east. And if, let's say you want to find a difference between 85 degrees east and 10 degrees, what are we supposed to do? You have to subtract because they are found on the same. So if you say 85 minus 10, you get 75, this answer here. So I'm sure you have the full information. So this is what we can do. So now let's move on to question 10. So question 10a, the probability of a girl not wearing a necktie is 0.55. What is the probability that the same girl who wore a necktie? So probability of one thing to happen plus one plus that thing not happening is equal to 1. So say probability of wearing plus probability of not wearing. We only have two outcomes, must add up to 1. So what is the probability of not wearing? We are given is 0.55. So if you are good with decimal numbers, you can just take it as a decimal, or if you want, you can convert that as a fraction. So maybe let's convert this as a fraction. It may be easy. So 0.55, how many decimal places do we have? So we have 1, 2. So you just have to get the number, this one before the decimal, so which is 55 over, since we have 2 decimal places, so it's over 100, 3 over 1000, like that. So the probability of wearing is what we are solving for, plus the probability of not wearing is 55 over 100 is equal to 1. So collect the like terms. So whatever number that we have here, whether decimal or fraction, must go to the other side. 1 minus 55 over 100. So we know what you do here, over 1. So lowest common denominator is 100. 1 into 100 is 100 times 1, which is 100, minus 100 into 100 is 1 times 55, 55. So 100 minus 55 will give you 45 over 100 as our final answer. So then the other picture here is, if you have a probability like 55 over 100, the other probability is what number can we add on 55 to be equal to 100? So it's 45 over the same 100. That's a pattern. Or you just get this 55, you subtract it from 100, you have the probability of what you are looking for. Then if you try to convert this into a decimal, this will give you 0.45, so it's the same. Now let's move on to question B. Given that 8 raised to the power x minus 1 is equal to 16. So find the value of x. So how can we solve for the value of x? So first, let's see if we can make these bases the same, because we can see that on the left side we have 8 as our base, then here we have 16. So we need to, let's make 80 as 2. So by what number can we raise to 2 so that it give us 80 is 3? We know that 2 times 2 times 2 times 2 will give us 8. So minus this. So this 16 can also be broken as the same base, which is equal to, this should be raised to the power 4. Then the rules of indices, we can multiply this power by whatever that we have. So this will be 2. 3 times x is 3x. 3 times negative 1 is negative 3, is equal to 2 raised to the power 4. If the bases are the same, then the powers are also the same. So we'll just now focus on 3x minus 3 is equal to 4. So let's shift this number. We have 3x is equal to 4 plus 3, which is adding up to 7 over 3 over 3. So what's our x? X is equal to 7 over 3. So this is what we are supposed to do. So just make the bases to be the same. From there, you will, if the bases are equal, then the powers also must be equal to. So you just equate to that. Okay, so we now go to 11a. Given that s is equal to x, such that 1 less than x less than or equal to 15, x is a prime number, lists the elements of set S. So what are prime numbers? Prime numbers are numbers with two factors, 1 and itself. So we are looking for numbers that have only two factors. So let's write this. So 2 is a prime number, and 2 is where we are starting from, so because we can say that we just need a number greater than 1. So 2, what else? We have 3, what else? 5, 7, 11, 13. So this is our final answer. Because in 2 we have only 2 and 1, 3, 3 and 1, 5, 5 and 1, 7, 7 and 1, 11, 11 and 1, 13, 13 and 1. So that is our set here. The diagram below shows a right square pyramid ABCD of base 6 centimeters and EF 5 centimeters. So the question is calculate the total surface area of the triangular faces of the pyramid. So we only need the faces of the pyramid. So how can we solve this? So a square base, can we find the area of one triangle? Okay, so we have been given, so let's, from here up to here is 6 centimeters. So from F to B is 3 centimeters because it's just the half of that. So we have the base. Now if we have the base, we need this height FE. Now how can we find this height? So let's do this. If we draw a line from here up to here, so this is a middle party, we also have a 3. So if we take this as a right angle triangle, we can find in fact we already have the height. So 3, if we square 3, we can find this distance, this slanting one. So 3 squared times 3 times 3 will give us 9. 9 times that will just give us we can just go direct. Okay, I've seen the point here. So let's just find the area of one right angle triangle. So we know that the area is equal to half BH. So it's half. The base is given is just 6. This line here. Then 6 centimeters times the height is 5 centimeters. So 2 here is 1, 2 here will give us 3, 3 times 5 will give us 3 times 5 will give us 15 centimeters squared. So this is the area of one face. Now remember, the question is the total surface area of triangular faces. So we have 4 faces. There is this one, there is 2, there is 3 here, 4. So for us to find the TSA, we just have to say 15 centimeters squared times 4, which is giving us 60 centimeters squared. Okay, so we move on to question 12. Okay, so question 12, we are dealing with now functions. A function f is defined by f of x is equal to that. So functions have the same pattern. The good part about functions, if you can just understand one question, you'll be able to tackle any question. Now let's look at what we are given. So there is this function f of x is equal to 2x minus 5. Find f of inverse. So step number 1, where there is f of x, you replace with y. So y is equal to 2x minus 5. Then what do you do? Make x the subject of formula. So this will shift to this side, giving us y plus 5 is equal to 2x over 2 over 2. X is equal to y plus 5 over 2. So after we are done, we can say therefore f of inverse of x is equal to whatever that we have formed on the other side, which is x. So where there is y, we bring back our x plus 5 over 2. Then for for b, we have f times the f of inverse. So this is now a composite function. So we have f of inverse. So let's find this expression. We'll begin with f, then the inside function will be f of inverse of x, since we have this. So the original function of f is this one here. So you say 2x minus 5. Now where there is x is where we're going to put the f inverse of x. So this is 2 open brackets. So where there is x, we put this. So we can cancel this, which is x plus 5 minus 5. So x, this will cancel, giving us x. So this is the expression, but the final answer now will be -2. So where there is x, we just put -2. Then the value of x, if f of x is equal to x. So let's again write this expression. So f of x is equal to, let's first find this. So this will be f, the inside function will still be f, since we only have f. So the f function is 2x minus 5. So this means that where there is x, we put the same function since it's the same letter. So 2x minus 5 minus 5. So 2 times 2x will give us 4x. 2 times -5 will give us -10 minus 5, which is 4x minus, here we get 15. Remember, whatever that we are going to form here must be equal to x. So we put x here. Then what do you do? Correct the like terms. So this will be x minus, the positive 4x will change to -4x is equal to minus 15. this is a minus. So here we'll get negative 3x is equal to negative 15. What you do here, to isolate this, we divide by negative 3. So x is equal to positive 5 as our final answer. So we can now move on to question 13. Now question 13, we have 13a. The diagram here shows two figures P and Q on the XY plane. Describe fully the single transformation that maps P onto Q. So we have 6 transformations. There is a translation, reflection, rotation, enlargement, stretch, and shear. So we want among these, which transformation are we looking at? So we can say that the size of the image is equal to the size of the object. So this cannot be enlargement. Enlargement, the sizes differs. Stretch, the size differs. Shear, the size also differs. So this can be rotation, it can be reflection or translation. Now we can see this, the way they are facing. So this should be reflection. Now what are we supposed to do whenever you are dealing with reflection? So we need to find what we call mirror line. So the mirror line is a line in between the two, such that the distance from this line to the image must be equal to the distance of that line to the object. So this is our mirror line. You can see that this distance here is equal to this distance here. So what equation is this? This equation is y is equal to 2. So in your description, just make sure that you mention the mirror line under reflection. So say triangle, it's not a triangle, we'll just say figure P was mapped onto figure Q by reflection in the line y is equal to 2. You have it. Then we go to question B. Under question B we have a calculus question, and the calculus part that we need to use here is the differential, because it's differentiate. So we need to have the differential. Now before we differentiate, let's write the equation. So it's y is equal to 2x raised to the power 3 minus 4 over x squared. So before you differentiate, if you have a variable on the denominator part, you need to bring it to the top. So this will be y is equal to 2x to the power 3 minus 4x. Now the power will change from positive to a negative number. Then after we are done with this, we can now apply the power rule. So dy over dx is equal to, so what you do, this 3, you bring it to the front, so this becomes 3x. Then after you bring it down, you subtract a 1 minus 4. So you repeat the pattern the same. So this will be negative 2x, then negative 2 minus 1. So we can expand this. So 2 times 3 will give us 6. X raised to the power 2. 3 minus 1 is 2. Then negative 4 times negative 2 will give us positive 8. X raised to the power negative 3. Same signs, we add and maintain the sign. Then our final answer, whenever the power is negative, you leave your answer by making it as a positive index where we take our x back to the bottom. So this becomes 8 over x raised to the power 3. So this is the required answer. So we move on to question 14. The diagram shows 3 points OA and B in which OB is equal to AB. Given that the bearing of A from O is 30 and angle ABO is 40, calculate the bearing of B from A. So first we are going to write to extend some lines for each vertex. Then these 3 lines are perpendicular, and apart from being perpendicular, not perpendicular, but they are parallel. So what you do if they are parallel, so there are some rules that we can apply to find certain angles. Now, before these 2 lines are equal to each, so if they are equal to each, the angle at this point and at this point is equal. So whenever I deal with an isosceles triangle, the base angles are equal. So how can we find that base angles? So let's get 180, because the sum of 3 angles in a triangle adds up to 180. So if we get 180 and we subtract the 40, the remaining angle is 100. So if we divide 100 by 2, this tells us that here we are going to have a 50. Also here we are going to have a 50. So if that is the case, so look at this point here. If you have this, as long as these 2 lines are parallel, this angle is equal to this angle. So we can apply that. So if there is a 30, also here there is a 30, then here there will be a 20, because 30 plus 20, we still have our 50. Now let's look at the first question. So the first question is B from A. So what is our B from A? So B from A, B from A. So this is our A. The bearing is coming from A going to B. So this line that is vertical, always consider the line as vertical where the bearing is coming from. So since our point A is here, so this line is A. Then remember to move in a clockwise direction. So we'll move like this, then until we touch the line that is being shared by A and B. So what angle is this one? This angle should be 120, because a straight line, not 120, this should be 170. This should be 170. Is it 170? 160. Since a straight line adds up to 180, 180 minus 20, we have 169. 160, I mean, so that is the angle here. Then O from B. O from B. So this now, this vertical line becomes our B, then this one becomes our O. So we are coming from B, going in this direction until we are here. So if that is the case, then how can we find this angle? So how can we find this angle? So let's say if this is our 20 here, also we are going to have the 20, and I'm sure I made a mistake. Okay, there is a slight mistake. Made a mistake by making calculations. Okay, let me just redo some of the numbers. So we said 180 minus 40 will give us 140. So 140 divided by 2, so this should be 70. If this is 70, here we have 30, then here we have 40. Then 18 minus 40, we get 140 here. So it shouldn't be this number, it should be, sorry for that. So this should be 140. So if there is a 40 also here, we are going to have a 40. So the other angle will just be 360 minus 40, which is equal to 320. So that's our final answer. Okay, so we're moving to question 15. The values of x and y are given to one decimal place as x is equal to 4.2, y is equal to 7.3. Find the maximum value of that. So this is all about just addition and subtraction of decimal numbers. So what's our x? X is 4.2 plus 7.3. So whenever you are adding or subtracting, just make sure that the decimals are in the same line. So 2 plus 3, we have 5. 4 plus 7, we have 11. So this is our maximum number. What of our minimum number? So minimum value, we do the same, is 4.2. It's 4.2 minus 7.3. So how can we subtract these numbers? So we just have to use the mathematics where we say different signs, you subtract and get the sign from a bigger number. So if we begin by putting 4.2 on top, this will not work out. So let's just do the reverse. Then you see what is happening here. So we just say negative 7.3 plus 4.2. So it's the same. So here we know that different sign, you subtract, which is giving us 1. Here we get, so the answer is negative 3.1. That's what you're supposed to do. So mathematics paper 1 is just all about thinking of also how good are you with numbers. So that's what you just have to do here. It's all about numbers. You just have to look at is this going to work or not. Then here 16, it is given that y varies inversely as the square of x. The table below shows so. Y varies inversely. So inverse is over 1 over square of x. So square, the x must be squared. So we'll say y. This changes to equal sign. Then k over x squared. So we have our equation. So let's find the value of k. So y is equal to k over x squared. So let's use this. If we use this pair, y is 9, k we don't have, over 2 times 2. So 9 is equal to k over 4. Over 1, we cross multiply. 1 times k is k. Then 9 times 2 is 18 plus 18, which is just 36. So k is equal to 36. So if k is 36, find the value of a. A is here, is in the y. So y is equal to, we have 36 as our k, over our x is 6 times 6. So it's 36 over 36, which is y is equal to 1. Therefore, a is equal to 1. And what else? Values of b. So b is here. So b is where there is x. So y is 4. So say 4 is equal to 36 over x squared over 1, we cross multiply. So 4 times x squared is 4x squared. Then 36 is same as 9 times 4. Or if you want, you can just write as 36. So that if you divide by 4, you divide by 4. The 4's can cancel. Then we have 9. We take out the square root. So we have x is equal to plus or minus 3, which is b is equal to plus or minus. So we have two values. That's why there is this plural, values of b. So that's our answer. Okay, so we have circle theorem. In the diagram below, A, B, C, and D lie on the circumference of the circle center O. Now for this topic to make sense, make sure you first understand the properties. So given that angle BAD is equal to 47 and angle DBC is equal to 28, calculate BOD. So BOD, this angle. So remember the angle at the circumference is twice the angle at the center. So that is the principle that we are supposed to use. So B or D will just be 47 times 2. So if you are finding the angle on the center, you multiply by 2. So 47 times 2 is just 45 times 2, 90, plus C, which is just giving us 94 here. So there is 94 here. OBD, this angle here. Now DO is a radius, so is OB. So if these two are equal, then we can use this principle of isosceles. If these two distances are equal, then the base angles will also be equal. So we can just put x here, also x here. So say x plus 94 is equal to 180. So x plus x is 2x plus 94 is equal to 180. We collect the like term, so 2x is equal to 180 minus 94, which is 2x is equal to 86. We divide by 2, So here we are just going to have 43. So there is a 43 here. Also there is a 43 here. So 43 plus 43 we have 86 plus 94 we have 180. So there is a 43 here. Then BDC, BDC. So what angle is this one? How can we find this angle? Now remember, ABCD is a quadrilateral. So whenever we have a cyclic quadrilateral, the opposite angles adds up to 180. So to find angle C, we can subtract 47 from 180. So that's what we are going to do here. So let's subtract 47. We get 1 from 8. 10 minus 7 is 3. Here we have 7 minus 4 will give us 3. So there is 133. Then if we just take CBD, this is just a triangle. So let's just put x. So say x plus C 133 plus C 28 adds up to 180. So 133 plus 28. So 8 plus 3 is 11. We keep the 1. 3 plus 2 is 5 plus 1, 6, so this is 161. So x plus c 161 is equal to 180. Then we shift this number to the other side, so it's 180 minus 161, which is what is 180 minus 161? This will give us 19. So the angle here is just 19. So we go to question 18a. The diagram below shows a right-angled triangle PQR, given that PQ is equal to 15 centimeters and cos x degrees is equal to over 3. Calculate the length of QR.